Okay, so it says the graph below shows the line y equals 8 minus 4 thirds x. So this line right here, that's the equation of that line. Okay, it says a line segment. Oops, there we go. A line segment connects the fixed point 7, 6. So here's this is the point out here, 7, 6. And this is any old rent. Well, we want to know what is the point here that's closest. That's what we're really looking for with any point x, y. You can click right here. Let me show you. We basically want to find what point is along here. Which of these points is closest? It's somewhere right around here, right? Here, let me show you the thing in motion. Here it is. So if I grab this, I can move it on this thing. See how you can move it? So you want to find as you move I'm moving the X on the bottom here. As you move the X, it goes. So where's the one that's closest? Small, right around there, looks like, you know? That says 3.5. It's pretty close. I think that looks like about the closest point. It's got to be a 90-degree angle, doesn't it? To find to the closest distance between a point and a line is a straight line 90 degrees right at it. So that looks about right. That's telling me distance 3.5. The real answer is 3.48. That's pretty close. So that's what we're looking at. So anyway, how do we calculate that? Very, very practical question used all the time in military applications, police, when targeting when they program targeting computers, to the closest point, medical applications, all the things in our bodies they target shortest distance. Engineering makes shortest distance things all the time, computer science. Very, very practical. How do you find the closest point between a line and another point that's off that line? So basically, you want to for all these different lines, you want to find the one that's minimum distance. That's what closest means, right? It says so down here it says minimal length, the point closest. So first off, here's the setup. We did this in another question. We found the equation using the distance formula between which shows the length of the line segment. This is L of x, the length of this line segment right there. Um, between the point and the straight line. So between the point and the straight line, L of x, there's the formula for the length of that line segment. And so um, now we want to take that equation and we want to minimize it, right, to find the minimum distance. All right, so let's do it. So we want to take that thing and minimize this. Let me bring it up here. We want to minimize L, which is the square root of, so x minus 7 squared plus, and then this, which is 8 minus 8 sixths x minus 6 squared. Okay. Now, how do we minimize something? We take the derivative set it equal to 0, so we got to do L prime set it equal to 0, right? Because when peaks and valleys at the top, the slope is flat at the bottom. Derivative L prime is the slope, with the L prime is 0 at the minimums and the maximums, right? When you're at the top and the bottom, that's when your slope is flat, your L prime, your slope, your derivative is flat. So, okay, so that's our game plan. So let's do it. But the trick is, you know what? I'd rather this got a big old square root. That's a little bit painful to take the derivative of a big old square root. I mean, I could do it. It's not the end of the world. But, is there an easier way? Yeah, that's where I give you this hint down here. Hint. To make the work easier, first find LOX squared by squaring both sides, and then just find the minimum of that function, since the same x value will make both L of x and L of x squared minimal. What am I talking about there? Let me show you. Let me show you. I made a little table here. I just picked out some random x values. X is 2, x is 3, x is 4. And here's the function, and I plugged in 2 right there, worked it out on Desmos, got square root of 25.44, plugged in 3, got square root of 20, plugged in 4, got square root of that. So which of those is minimal? Which one of those is lowest? Well, this one, right? Or let me write it over here. So this one is the min, right? Square root of 20 is lower than the square root of 20.11 or 20. So that means x equals 3, right? But then I also showed here I squared them. I just squared them. I just removed that. So if you square this, it just removes the root, right? So which of these is lowest? Well, same one, obviously. So the point is x equals 3 is going to lead to the lowest square root and the lowest second power. Does that make sense? You're going to get the same answer. So if you're looking over here at the L squared, saying which of these is lowest, the x value you get is going to be the same x values if you look at the square roots and say which of these is lowest. Same x value. That's my point. If we come back here and we just square this thing and do the minimal, we're going to get the same x value. It makes no difference. So, and that's easier. So square it, and so L squared now is easier to deal with. And so we have, oh wait, we don't have the root. That's the point. Squaring cancels the rooting. I don't know what I'm doing there. X minus 7 squared plus 8 minus 8 6x minus 6 squared. There we go. No more root. Much nicer. Now we're going to minimize that. How do we minimize it? We take the derivative, and set it equal to 0. So let's do the derivative. Bring down the 2. Wait, I hope we're going to have room. Make sure we have room here. So I'm going to take the derivative. Let's bring down the 2 times 1, the chain rule, the inside's 1, plus, same thing, bring down the 2. To the 1 power, because you subtract 1 in these guys. But then times, chain rule, what's true to the inside according to the chain rule, right? You keep the inside the same at first, and then drew to the inside, that's going to be negative 8 6, isn't it? Here, let me make that smaller. So I got to still set it equal to 0. Negative 8 6, and then I'm going to set it equal to 0. Okay, so I got to solve that equal to 0. Let's do it. Let's distribute the 2. So I'm going to get 2x minus 14. The times 1 doesn't do anything. Plus, and then distribute this guy. It'll be 16 minus, what's that? 16 over 6. That 2 just goes to the top. X minus 12. Oh, wait a minute. Yeah. Then I gotta multiply by negative 8 sixths. It's a little messy, isn't it? All right. Equals 0. Yeah, here, let me do that better. Way that'll be easier for you. I would just put these guys together first. This 2 is minus 8 6. Look what they are. Let me do them over on the side here. 2 times minus 8 sixths. Oops, that a little bit better. This is 2 over 1 minus 16 over 6. Reduce that fraction minus 8 thirds. So put them together. I'll go plus, so it's going to be minus 8 thirds times the 8. And I'm going to make this 4 thirds x. I'm going to reduce this 8 sixths minus 6 equals 0. So see what I did? I did this minus 8 6 and this 2. Since they're multiplying, I just put them together in the front, right? These are just 3 things multiplying. You could do them in any order. I'm saying just do the 2 and the minus 8 6 first. Did that right here, simplified it. And I also simplified that, guys, trying to make this easier because the numbers are a bit messy, and this is the easy version without the root. So now distribute that. Minus that 8 goes to the top, 64 thirds. Plus, negative negative. So that 32 ninths. Plus 6 times 8, 48 thirds. Equals 0. Okay, get rid of this. So now, let's combine. This is an x and an x. So 2x. So you can use Desmos 2x and 32 ninths. You can do it by hand. I'll show it over here. 2 plus 32 ninths. This is 2 over 1, right? You got to get a common denominator, multiply top and bottom by 9. 18 ninths 32 ninths. What's that? 50 over 9? 40, 50. Yeah, 50 over 9. So that'll make it 50 over 9. You can do it on decimals if you need to. X. Okay, now what about the other numbers? Then we've got minus 14. Oh, um, yeah, minus 64 thirds. Let's put that. We got to get common on. Put that over 1. So if I go and then I'm going to multiply top and bottom by 3 to get a common denominator. That'll be minus, what's that? 30, 12, 42 over 3 minus 64 over 3 plus 48 over 3 equals 0. Some ugly fractions here. 50 over 9x. And then these three combined, use your calculator if you need to. I need minus 106. Wait, what is it? 6 minus 64. Um, it's minus 58 thirds. I think it's minus 58 thirds equals 0. We are close. This one just won't finish up for us. And then bump this to the other side. 2 over 9x is positive 58 thirds. All these fractions, huh? Let me show you how to do this without fractions. Probably I should have done that earlier. Times 9/50ths on both sides to finish getting x alone. Zip, zip. So what do we got? Remember how to do this? 3 goes into 9 3 times. 3 times 50, 150 and 24, 150 and 24, 174 over 50. Reduce it, divide by 2. Divide, what is that? 80 and 14. 87, 116, 14, 87 25ths. Whew, is that what x was? Oh, they gave us a decimal. 3.48. Is that what 87 25ths is? Let me check Desmos. 87 25ths. 87 25ths. There it is, 3.48. We got it. Okay, so that was messy. Let me show you. You probably should have just done that. Having done all that, that was terrible. I would just, well, yeah, I mean, you could do any of that on Desmos. Yeah, any of that on Desmos. I did a bunch of fractions, but you could, how about I just redo that real quick? What if instead you just use Desmos to do those steps? So, right here. Yeah. So when I've got it, let me show it one more time. So when I've got the 2x minus 7, I'm looking right here, uh, plus 2, and I'm going to go times, come on, minus 8 6, parentheses, 8 minus 8 6x minus 6 equals 0. Yeah. So how would I use this in Desmos? Well, first off, I would just do these guys on Desmos, 2 times minus 8 6. Let me show you what I mean. So I'd go 2 times minus 8 6 like that. Boom. And now you hit that little button, see this button over here? It'll change it minus 8 thirds for you. You go, oh, okay, that's minus 8 thirds, which I showed you how to do that. But that would be quicker. Minus 8 thirds. You could just use Desmos like that. Okay. And then I'm just going to keep showing you about Desmos. Desmos will do these fractions, distribute here. And then when you distribute this guy, boom, 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 just do them on Desmos. Well, you don't need Desmos for that. That'd be minus 64 thirds plus, and this is going to be 64 18ths. Well, again, I would reduce this. Let's do that. Let's reduce that. I'll make that 4 thirds. And that'll be 32 ninths. Right? 32 ninths. X. And then 6 plus 48 thirds equals 0. And down to 2, so minus 14. Yeah. Now, as far as this and this and this, I would just go on the calculator. Minus 14, minus 64 thirds, Desmos, minus 14, minus 64 thirds, minus 14, minus 64 thirds. and minus, was it 48 thirds or something? This is just, I don't know if you recognize, this is just 16, but that's okay. Plus 48 thirds, plus 48 thirds. So plus 48 thirds. Boom, there we go. And hit the button. Minus 58 thirds. So those guys make minus 58 thirds. So minus 58 thirds on those. And then these two, 2x and 32 over 9. Just add 2 and 32 over 9 on Desmos. 2 and 32 over 9 on Desmos. 2 plus 32 over 9. Desmos, hit the button, fraction button. 50 over 9, x. I just took the x off, right? 50 over 9x equals 0. Bump this over. 50 over 9x equals positive 58 thirds. And then, like we said, multiply by the upside down. So I'm just I'm just doing the same thing. I'm just showing you how to use decimals if you're having trouble with some of those fractions. X equals, now 58 thirds times 9 fiftieths. 58 thirds times 9 fiftieths. We have 58 thirds. 58 thirds times 9 fiftieths. Boom, 3.48. There's a fraction or decimal 3.48. There we go. So there it is on Desmos. You can do the fractions on Desmos. And so there we go. We found the x value. And it was pretty close to what we thought, right? We thought it was around 3.5 would be the point closest. And it came out 3.48. There we go. So very useful in many kinds of applications is finding the point closest to another point from a line or a curve. And so there we go.